Welcome back, everybody. This is going to be part 1 of 2 on my lecture series on linear functions. Let's get started. Remember that linear functions are just degree 1 polynomials. An important characteristic of the graphs of linear functions are their slope. Here, I have the slope formula, and this is going to be an important one for you to remember. The slope is the rise over run, or the change in y compared to the change in x. Between 2 points, the line that passes through those has slope y2 minus y1 over x2 minus x1. Let's see if we can use this formula to find the slope of the line passing through -1, -2, and 1, 4. It doesn't matter which point you call your first point, as long as you just stick with your choice. So I'm going to call this one point 1, and this one point 2. The slope then, we usually use m to denote slope, is going to be the y-coordinate of the second point minus the y-coordinate of the first point, rise over run. Y-coordinate of the second point minus x-coordinate of the second point minus x-coordinate of the first point. This gives me 6 over 2, or 3, to be the slope. The reason slope is so important is because it allows us to write down the equation of a line. The equation of the line with slope m that passes through the point x1, y1 is this. Y minus y1 equals m times x minus x1. And we call this the point slope formula. This is going to be another formula that is going to be important for you to have memorized for the exam. Let's see how we can use it to find the equation of the line with slope -3 that passes through the point 1, 2. Well, I know from the point slope formula, it should be y minus y-coordinate equals m. Remember, that's the slope, -3 times x minus x-coordinate, 1. So this would be the equation of that line. Why don't you pause the video here to see if you can tackle the next problem on your own? Both of these lines on the right are correct answers to the problem. Notice that this had the extra difficulty that the slope wasn't provided. However, we did have means of getting it. Just like in the first example we saw, we know how to calculate the slope between, the slope of the line that passes through 2 points. I found it to be 1 using the slope formula. From there, I just have to plug all of my information into the point slope formula. And it doesn't matter what point you use to get the equation of the line, it should be the same line, which we'll see here in just a little bit. So, using 2, 4, you get the top result. Using -3, -1, you get the bottom result. Now, how are these the same? Well, we would have to write it in slope-intercept form, which is something you are probably familiar with, in order to verify that. The equation of the line with slope m that has y-intercept 0, b is y equals mx plus b. This is, you guessed it, another formula that you should have memorized for the exam. I promise I will try not to make too many formulas you have to have memorized. Let's use it to write the equation of the line with y-intercept 2 and slope -4. Well, I write y equals m is my slope, so -4 times x plus b. The y-intercept happens to be 2, so I add 2. That's all there is to it. Notice that I can convert between slope-intercept and point-slope form pretty easily by just solving for y. If I do that with the problem above, and let me move my annoying head out of the way, I distribute my 1 and then add 4 over and get y equals x. I'll have minus 2 plus 4 is plus 2. Down here, I'll have x plus 3, but I'll subtract 1 over and get y equals x plus 2. So those are the same line, and it's easier to see once I write it in slope-intercept form. I've got a couple challenging problems for you. Let's start with the pink one. Pause the video here to see if you can tackle it on your own, but if you need a hint, let the video play a little longer. Ready for the hint? I'm not explicitly given the slope of this line, but I am given 2 points that it passes through, so I can use the slope formula to find it. The equation of this line is y equals 3 halves x plus 3. Notice not only was the slope not explicitly given to us, they also kind of tried to hide the fact that the y-intercept is given right here by not labeling it as the y-intercept. But remember, the y-intercept is whenever the x-coordinate is 0. So I know my y-intercept is 3, and I can calculate the slope to be 3 halves. So using the slope-intercept formula, I get y equals 3 halves x plus 3. One more tricky problem for you. Find the x and y intercepts of 8x minus 4y minus 12 equals 0, and then use them to sketch its graph. If you need a hint, let the video play a little bit longer. Ready for the hint? X-intercepts occur when y is equal to 0. So what I do is set y equal to 0 and see what I get for x. Turns out to be 4/3. See if you can use this to grab the y-intercept as well. Pause the video here and press play when you're ready. I found the x-intercept to be at 4/3 and the y-intercept to be at -3. To find the x-intercept, remember that's where y is 0, so set y equal to 0 and see what you get. Same thing for the other case. To find the y-intercept, remember that's when x equals 0, so I set x equal to 0 and see what happens. I get y equals -3. Remember, all you need are 2 points to find the graph of a line, so when I plot the x and y intercepts, I can quickly sketch the graph. That's going to wrap it up for this video. I hope that you're taking away, first of all, the slope, point slope, and slope-intercept formulas, and then also how to use all of those to write down the equations of lines and sketch their graphs. In the next video, we're going to talk about parallel and perpendicular lines. Catch y'all in the next one.